Hey everybody, in this video we're going to be practicing mean value theorem. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. So the idea of mean value theorem is that we look at a function on an interval. And what we first do is we say, what is the slope of that secant line? And then we ask, on that interval, when does the function have that slope at its tangent line? So the first thing we have to do is we have to identify what are the values of the endpoints. So here we've got an interval of 0 to 1. So if I plug in an x value of 0, I have e to the 0. So anything to the 0 power is 1. And then if I plug in 1, e to the 1 is just e. So then I use that to find the slope of the secant line. So that's going to be, so together that makes, let's see, e minus 1 over 1. So that is e minus 1. Okay. So that is our value of our slope. So now what we do is we set this equal to the derivative and find when the derivative equals that. All right. So what we do is we say that f prime of x equals e to the x. All right. So now what we do is we set e minus 1 equal to e to the x. So how do we get x out of there? Well, what we do is we use logarithms. We use ln. So ln of e minus 1 equals ln of e to the x. And these will cancel and just leave x. So we have ln of e minus 1 equals x. Now, we want to be sure that it falls between 0 and 1, so I'm going to take an approximate value of e minus 1, and so that is approximately 0.541. If it weren't in this interval, we wouldn't count this value, but as it turns out, it is on the interval from 0 to 1. So there's our exact answer, ln of e minus 1, and then 0.541 is our approximate decimal answer. So moving on to the next one. So we have the interval from -2 to +2. So if we plug in -2 here, we're going to get, let's see, 16 minus 16. So that should be equal, so that should equal 16. And if we plug in 2 to the 4th, that's 16 again. -4 times 2, that's also 16. So what we end up with is we end up with a slope that is equal to 16 minus 16 over 2 minus -2. We get a slope of 0 here. So this is a unique example that's similar to Rolle's theorem, and I have a whole separate video on this playlist dealing with Rolle's theorem, where the slope of the secant line is equal to 0. So now what we do is we find the derivative, f prime of x equals 4x cubed minus 8x, and we set that equal to 0. Set that equal to what our secant line is, the secant slope. So 4x cubed minus 8x equals 0. So what can we do? Well, we can factor out a 4x, and we're left with x squared minus 2 equal to 0. So I set each part equal to 0. So 4x equals 0, so we get x equal to 0. So here is a spot where the tangent line will equal the secant slope, and that is on our interval, so we'll include that. Then we set x squared minus 2 equal to 0. Add the 2, so x squared equals 2. So x is going to equal plus or minus square root of 2. And both of those also fall on that interval. So we have 3 points on the interval from -2 to 2 where the tangent line has a slope of 0. All right, moving on to number 3. So here we've got this function x minus 2 over x, and we have the interval from 2 to 4. So from 2, if we plug in 2 minus 2 is 0 over, doesn't really matter, we get 0. Then we plug in 4. So 4 minus 2 is 2 over 4 is 1/2. All right. So now we find our slope. So 1/2 minus 0 over 4 minus 2. So we get 1/2 over 2, which is 1/4. That's the slope of our secant line. Now we still need to find the derivative, f prime. Now this is going to require some quotient rule. So low d high, so that's going to be x times, well, the derivative of the top is just 1, so no need to write that, minus high d low, and the derivative of the bottom is also 1, so we don't need to write that either. And we can simplify this a little bit because we're going to have x minus x plus 2. So we have 2 over x squared, and that equals f prime. So now what we do is we solve for 2 over x squared. So I can treat this as a proportion, and I can cross multiply these. And so we have 2 times 4 is 8, x squared times 1 is x squared. So when we take the square root, we have plus or minus the square root of 8, which simplifies to plus or minus 2 square root of 2 equals our x value. But here's the thing to keep in mind. We're only looking at the interval from 2 to 4. So actually, we're not even concerning ourselves with the negative value. We're only concerning ourselves with positive 2 square root of 2 equaling x. So now, on to number 4. Here we've got x cubed minus 9x from negative 3 to positive 3. So if we plug in negative 3, we should get negative 27 minus 9 times 3, so that is a positive 27, so that equals 0. If I plug in positive 3, I get 27 minus 9 times 3 is 27, is 0 again. So this is another example of one similar to number 2, where the 2 points have the same y value, so the secant slope is 0 over 3 minus negative 3, but that still ends up being 0. So if we find the derivative, f prime of x equals 3x squared minus 9. So now we set this equal to 0, equal to the secant slope, 3x squared minus 9. And so when we solve, we add 9. So 3x squared equals 9. Then we divide by 3. X squared is going to equal 3. And so x is going to equal plus or minus square root of 3. Now in this case, both of them fall within the interval of negative 3 to positive 3. So for this problem, number 4, we have 2 answers, not 1. So now looking at number 5, we have the interval of 1 to 4. So for our endpoint, 1, when we plug in 1, we get 1 minus 9 is negative 8 over 3. So negative 8 thirds. And then 4. 4 squared minus 9 is 7. Over 3 times 4 is 12. So 7 over 12. So to find our slope here, we have 7/12 minus negative 8 thirds all over 4 minus 1. So we've got a little bit of a fraction within a fraction here. So I'm going to rewrite this 7/12 plus, because we're subtracting a negative, I'm going to rewrite this with a denominator of 12, so I can simplify that. So that means I multiply the top and the bottom by 4. All right, so here we've got 32 and 7, so that makes 39 over 12 over 3. Now one trick that I often use is, instead of dividing fractions, what we do is we take 39/12, instead of dividing by 3, we multiply by 1/3. And what that allows us to do is that allows us to see that, hey, 39 and 3, we can cancel out a common factor, leave 13. So our secant slope is 13/12. All right, now we need to find the derivative. So f prime of x, this is quotient rule. So we have low d high, so 3x times 2x minus high, x squared minus 9, d low, It's 3, all over low, that's 3x squared. T squared. I have to do a little bit of algebraic simplification here. So 6x squared minus 3x squared plus 27 all over 9x squared. Remember that we're squaring both the 3 and the x, so that means we get a quantity of 9x squared. And now the x squareds simplify down, so we have 3x squared plus 27 all over 9x squared. Now everything here has a factor of 3 that we can cancel out. So we have x squared plus 9 over 3x squared. All right, so now we set this equal to 13/12. So x squared plus 9 over 3x squared equals 13/12. And so here again we can cross multiply. So 3 times 13 is 39x squared, and then we multiply by 12, 12x squared, plus 9 times 12 is 108. So what we'll do is we'll subtract the 12 over to the other side. So we have 27x squared equals 108, and then we divide 108 by 27, and we get 4. So x squared equals 4. So when we take the square root, x is going to equal plus or minus 2. But wait a minute, we're only looking at the interval from 1 to 4. So the only answer that we'll consider here is positive 2, not negative 2. And so that is the only point where the tangent line has a slope of 13/12 on this interval. It's always a thing you got to be aware of. We only include the answers on that interval. All right, number 6. So we have the interval from 0 to 4. So we plug in 0 in for x. So that means these disappear, and we're left with negative 3. Now we plug in 4. So 4 cubed is 64, so that's negative 64. And then we plug in 4 here, so and that's positive 64, so that will cancel. And so we end up with one more example where the two endpoints have the same value. That means the secant slope there will be 0. So for f prime, that's going to equal negative 3x squared plus 8x. So when we set the derivative, negative 3x squared plus 8x equal to 0, that'll give us the points on this interval where the tangent line and the secant line have the same slope. Factor out an x. So we have negative 3x plus 8 equals 0. So we set x equal to 0 and negative 3x plus 8 equal to 0. Add the 3x, so 8 equals 3x, and then divide by 3, so we get 8/3 equals x. Now, interesting little detail about mean value theorem. Mean value theorem actually never includes the endpoints of the interval. So it's a nice happenstance that it does have the same slope on this interval, but mean value theorem doesn't always guarantee that this will happen. It only guarantees on the open interval. So mean value theorem by definition never includes the endpoints, but on occasion it does happen, and this is one of those occasions. It happens at 0, but it also happens at 8/3. Now for the last two examples, we need to explain why the mean value theorem does not apply. And the main reason why it wouldn't apply is it has to be a differentiable function. So looking at this function right here, we've got a problem. Because we've got a denominator, that means that this function could be undefined. It would be undefined when 4x plus 8 equals 0. So if I move the 8 to the other side and then divide by 2, x equals negative 2. And so at this point, f of x is undefined. And because it's undefined, that means it's not continuous, and therefore it's not differentiable on this interval. So therefore, because it's undefined on that interval, even if there's just 1 point is all it takes to mess it up. It has to be continuous and differentiable through the entire interval. So that's why the mean value theorem does not apply here. Now number 8. Number 8 is a peculiar one, especially if you don't have a graph. And so to illustrate this, we're going to write what f prime is equal to. A little bit of chain rule, but it's a pretty simple chain rule. If we take the derivative, we get 2/3 times x minus 3 to the negative 1/3 times the derivative of the inside is just 1. Now let me rewrite that as a fraction with radicals. So we have 2/3 times the cube root of x minus 3. Now this is the derivative again. Now in the previous problem, we had an issue where f of x was undefined. Well, here we have the same problem here where f prime of x is undefined. And here it's undefined at x equals 3, which is within the interval we're looking at. Now, if I were to plug in 3 into the above expression, it would work, at least for the function value, but not for the slope. So because the slope doesn't exist, that means it's continuous there, but it's not differentiable. And we need it to be differentiable as well as continuous. So that's why it does not work for this one. Thanks for watching. If you like this video, please give it a thumbs up. For more videos like this, click the subscribe button. If you're a teacher and this helped you, share it with your colleagues or your students. If you're a student and you like this and it helped you, share it with your classmates. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.